All right, so I apologize. Hopefully you can hear me. If you can hear me, can you please just type into chat that you can hear me? Okay, good, good. All right, sorry about that. I was trying to log in, and apparently I can't do that through the desktop app. I have to do it through the browser, which is fine. Just didn't know that. So hopefully I can get that straightened out at some point today. All right, so let me just close out of a few things here. All right, so I'm sharing here just so you can see. I'm sure you've already looked at this. Is looking at your blueprint for Nursing 130 for Boyce campus. All the campuses are the same as far as the blueprints, but sometimes the questions can differ a little bit. So if you've gone through and looked at some of my practice questions for like Allegheny campus, you might realize that some of these look a little bit different, particularly your intake and output calculation. Remember, that was one you did in 110 where you had like some foods with some liquids, and then you're just converting those liquids that are typically in the US kind of system, and then you're going to convert it to the metric system because that's what they want you to do. The oral meds are usually pretty straightforward. Most students are not struggling with those, nor the parenteral medications. Usually, where things get a little bit tricky is where you get into the reconstitution type questions. So I'm going to try and work through some of those. And then just for your sanity, when it says complex dosage calculation problems, all that really means is that it's a two-step problem. It's not any more complex. It just usually just means you have to convert a patient's weight in pounds to kilograms and then multiply and then incorporate the patient's weight in that calculation. So don't get too upset when you see things like that. It's just the way that it's worded. So give me 1 second. See, there was practice test sent out with some of the emails. Oh, okay, you're just answering each other's questions. Yeah. So in the email you got, it would have given you 3 links: the Zoom link, a link to my YouTube page where I post these recordings, and then it says click here for practice tests, and that opens up a Microsoft OneDrive folder that anything that I post in that area, that's for practice. And there's a lot of practice amongst the different campuses, so you can get some variety. It's always evolving, it's always changing. But for the most part, the practice questions haven't changed too much over the years, but there is things that get added every semester based off of necessity. So speaking of that, I'm going to open up a new Word document. And we're going to start off with kind of the ones that are a little bit more challenging. And then what my intention is, I'm going to put this into a new folder in the Dosage Calc practice. That way, you'll see that it's relatively new. So if you come back to that link, there'll be a new folder for 130. And within that folder, we'll have, I'll put for 23 fall. That way it is up to date and you'll know where to look for things. All right, so let me give you some examples of what a just give me 1 second, sorry. What a question that's considered a reconstitution would look like and how it might get asked, and then we'll kind of go from there. All right. So there's a couple of things on this that is extra information that you don't necessarily need to know as far as a reconstitution question is concerned. But I wanted to navigate this and just kind of show you what this looks like and how to answer questions that might pop up in regards to what is considered a reconstitution. Because I do think that reconstitution is new for you for this semester. I don't think you had that in 110. I'm going to double check. Oh, you did have a reconstitution. So hopefully this is not completely new. So just as a reminder, if it's been a little while, reconstitution just means that in the pharmacy, where it's stored, it's in a powdered form. They're adding water to it, and then it becomes a liquid, oral based medication, and that you're delivering and you're giving that to the patient as a way to obviously give them the medication. And it's no different than calculating an oral based medication. The only thing is that makes these a little bit more challenging sometimes is finding the information that you're looking for. That's what makes this, a little bit more challenging. And so one of the things that I'm going to try and do is just show you how you would look at this and then encourage you to pull up. If you just do a Google search for reconstitution questions, you should be able to find plenty of examples. And then I'll try and get some more together because I plan to meet with you guys also on Thursday morning um, if you're available. But if not, you can always email me questions too, and I'll try and get those answered if you find something. So again, I apologize if this is a repeat for you. But when we talk about reconstitutions, one of the things you pay attention to is the label. So first of all, I know at Boyce, they're not going to tell you to calculate the milliliters. They're going to say, how much are you going to administer per dose? And so you need to know, because this is a reconstitution, you already need to know that you're looking for milliliters, right? That's what you're going to be giving them is milliliters. Because again, we talked about reconstitution, oral-based medication. That's a liquid. So it's not a tablet, it's not a capsule. We don't measure in teaspoons and tablespoons unless they specifically ask. And so it's milliliters is what you're looking for. The trick for knowing that you're dealing with a reconstitution, because it may not have all this extra information listed, like for reconstitution and things like that, what you see is you're going to see a strength listed. It'll say 500 milligrams in a typical oral-based medication, liquid oral-based medication, like think Dilantin. Dilantin is like 125 milligrams per 5 ml. All right. That's one example of a strength of Dilantin. So it already tells you that milliliters is there. But on these types of reconstitutions, they don't tell you the milliliters right off the bat, right on the label itself. Or at least on the facing part of the label. You need to actually go into the instructions to find the information you're looking for. All right. And so what you're looking for in the instructions is you're looking for that same relationship that I mentioned before with Dilantin, 125 milligrams per 5 ml. You're just looking at for this ANSEF. Okay. And so you look at you come over here to the side, and you're looking over here and you're looking to see where it tells you. So it tells you our usual adult dosage range is 250 milligrams to 1 gram every 6 to 8 hours. The main reason you would want to know about that is because you want to make sure it's been ordered safely. And so if I go back and I look at my order says 0.375 grams every 6 hours. Okay. So 0.375 grams is the same thing as 375 milligrams. It's within that range. It's within that time frame. So we can assume that it's safe to administer. The other thing, and I always tell Boyce students this, South and North as well, think about what this means, right? IM means intramuscular. Intramuscular tells you it has to be in a liquid format. And so that's the other clue that what you're looking for is milliliters. Okay. So I'm just trying to give you some things that'll help you out, because what usually when people miss this question, it's because they don't know what they're looking for, or they start guessing on how to kind of answer the question. All right. So we know it's in the safe range. Then it says specifically for intramuscular administration, you're going to add 2 milliliters of sterile water. You might think you want to use that information. You don't. Which will make an approximate volume of 2.2 milliliters, which is better information. But what's the best information is it tells you the concentration it makes. 225 milligrams per milliliter. All right. That's what you're looking for. Normally, you would hope you would see that typically on the part of the label where this 500 milligrams is listed. You would see that 225 milliliters listed there, but that's what's different about these reconstitution problems. Once you know what your strength is or you're available for the ANSEF, now you can do your math. So I always say I take a little bit of time just kind of showing you this as like kind of our starting point. And so there's a couple ways you can do this. If you're doing ordered over half, right? 375 milligrams over the 225 milligrams. And then in this instance, your quantity is 1. You just plug that into your calculator. If I can get my calculator to turn open on my password. All right. So 375 divided by 225, it gives me 1.6 repeating. You know, based off of your rounding rules, that you would just round that to 1.7 milliliters. Now, the other thing that's helpful with this, so you won't see this extra stuff here, okay? You're just going to say, you're not going to see how many milliliters of diluent will you add. You're not going to see that on your, you're not going to see this. You're not going to see this. And you're going to see this, but it's just going to say how much will you administer. So it may not tell you the milliliters. It may not tell you that. That's why I was trying to tell you in the beginning that the milliliters would be, you need to know that in order to kind of solve it. But anyways, so that's what a typical reconstitution question is going to look like. This particular question, like I said, I'll have it available to you, but it's in the Boyce 230 folder. There's a study guide that was made for 230 by a student that went through the nursing program, so that way you have access to that. But I'm just going to create a new document just with a couple of the questions that are popping up here. So before I continue on with everything else, if you have a question about a particular type of problem, just go ahead and put that, type it into the chat, or if you want to unmute and just tell me what type of problem you'd like to see worked through, or I can just continue to work through problems and we'll just kind of figure out.
Dr. Rad, you just mentioned you're going to create a 230 folder. We're 130.
I know. I said that there's already a 230 folder that has a study guide, is what I said.
Okay.
And then the 130 folder I just created, but there's nothing in it yet. It's just going to be a few of these practice problems that I'm just picking and choosing from the other problems that I have. But it'll be more geared towards what you guys are working through. But if you look at the 230, really the only difference between the 230 and the 130 test is going to be the heparin questions, which you won't have yet, but everything else is on there. It's just a different quantity of questions. Yeah.
Got it. Thank you. I just was confused for a little bit. Thank you.
Oh, no. Thank you for asking. I appreciate that. It's a good question. Okay. Yeah, let's so let's bounce over to the IB questions and then okay. So yeah, and I know if you're coming in from the LPN program, there's going to be some differences. So one of the things I will tell you is like outside of this review, and then obviously try and come in to the review on Thursday because hopefully I'll have everything like I didn't know that I was going to have an issue with Zoom. Otherwise, obviously it wouldn't have been an issue. But make sure you come in Thursday morning. I'll try and be a little bit better prepared. But also, I would suggest reviewing the previous reviews I've done for 110 and the 130 classes, and they're on my YouTube channel, which you should have a link to. If you are missing any links, I'll give you my email address here. You can always email me, and I will email you those links because I don't have them like that readily available. Thursday is going to be the same time, 10:30 to 11:30. I don't know. I didn't get direct information to tell me whether or not I was supposed to do this Tuesday and Thursday or just Tuesday or Thursday. It wasn't completely clear, but I already have it blocked off on my schedule. So I plan to be here Thursday morning to do this review with you guys. So, all right. So let's work through a few IV type problems. So let me pull up a couple. So first of all, on your blueprint, it tells you IV therapy flow rate calculations, 4 questions. It does say primary and secondary. I have not really seen many secondary type questions that have been asked, but basically a secondary IV is just, from what I understand, is just that it's already going. You make some modifications and you just use the information to change that. But again, I've usually only seen the primary ones listed. But I'm going to pull up what I have here for you. So just give me 1 minute. Yeah, so these are good. It'll be good for you guys. So sometimes these will have I'm trying to can't get past this. What the heck? Okay. Anyways, sometimes these will have labels associated with them, but not always. So let me pull these up so you can see that I'm gonna get rid of the numbering here in just a minute. All right. Because the numbering doesn't really make sense at this point. And so it says you have 4. I'm going to give you 5. And we'll go through each of these here. And then you'll see them. Like I said, you'll have the questions available to you. So these are your IV flow rate type questions, like I mentioned. And what I'm going to do is I'm going to do one more thing. This will help actually with just so you know, like this is coming from one of the textbooks that I use as a reference. So when you see these page numbers, I can't remember the exact book that I use. I have to look that up. It's been a little while. So you don't need to worry about this too much. If you're looking for this and you're wondering where this is, I will have to find that for you.
Is it the green one or the white one?
It, the book that I used most likely was a different color, so I have no idea.
Okay.
I'm sorry. All right. So for IV flow rates, there's a couple things you need to know. First of all, oh, so some of these are drop factor. I don't even know if you have that, but we'll go through a few of those. So let's start off with just a basic. So I'm going to start off with this one here, the one that I've highlighted, a standard flow rate. So flow rate has a very simple formula associated with it. And that formula is that when you calculate flow rate, you're looking for volume over time, which is milliliters per hour. Okay. So sometimes you'll see it listed as cc's per hour, but typically what they're looking for is milliliters per hour. If you don't know already, milliliters per hour and milliliters and cc's are equivalents, but the common vernacular, I believe, is milliliter, unless you're watching like a drama and they're saying like, I need 4 cc's stat. I don't know if they necessarily say that still in like a real setting, but that's the example I typically hear cc's for. But now you know what it is if you didn't already. So if I'm calculating flow rate for something like this RL stands for Ringer's lactate. All you're going to do for this one is you're going to take the volume, which is 375 milliliters, over the time, which is 3 hours. And then you're going to reduce that. So you're just going to take 375 divided by 3 to get a flow rate of 125 milliliters per hour. I apologize for my handwriting. It's been a little while since I've used my notepad or my pad here to write. So that would be like, believe it or not, this is a commonly missed question because students are looking for more to do. They're looking for more math, but a lot of
So I'm so you, but I'm confused. Why wouldn't I put it over 24 hours first?
because it doesn't ask you to do that.
Okay, so you're right. Like I just added more crap.
Yeah, exactly. Because it doesn't tell you to, when you're calculating flow rate, it's kind of like your mileage on your car. If you're traveling 40 miles per hour, that's your rate. No, if I wanted to know how long you were or how many miles you covered in a day, then we would want to incorporate 24 hours. But we don't care about per day. We just care about what it is set to right now.
Okay, sorry.
Oh, that's a good question. Yeah, because there's nothing in here that would say to do anything with 24 hours. That's why but the only time you would need to do some sort of conversion is you might need to convert minutes to hours. And so then you might want to do an extra conversion. There's an example of that here with 2 of them down, the 120 milliliters in 90 minutes. So I'll show you how to do that one. But that was a really good question, and I'm glad that you brought that up. I'm not sure what you were trying to do with the 24 hours, other than maybe but you would have gotten to the same answer. You just would have added extra steps to get to that same answer. So I'm glad we sussed that out. So let's look at this next one, not the 250 ml, but the patient receiving a tube feeding, because this is another commonly missed question because of the conversion. And there's a variety of ways to answer this. The way I'm going to show you is the way that's consistent regardless of what the minutes are. Because many students look at this and they say, oh, 90 minutes, that's 1.5 hours, 120 over 1.5, and then I get 100, I think it's 180 milliliters per hour. Perfect. But what if it's not 90 minutes? What if it's 35 minutes? What if it's some other number other than 90 minutes? I wanted to give you a strategy that that can help out if you ever have to do this, and it's good practice too, because you're going to need to know how to convert minutes to hours anyways. So remember, I told you flow rate is just volume over time, but the time that we're most interested in is hours. So when I'm making, when I come up with a problem where I have volume over time, where it's milliliters per minute, I do want to incorporate and convert those minutes to hours. Now, this is where people, especially nursing students, hate what I'm about to do, but I'm going to do a conversion factor for, and what we're doing is dimensional analysis, which everyone hates, or everyone likes, depending on your thing. But the reason this is beneficial is because now we can see, first of all, you might have the question, do I multiply by 60 or do I divide by 60? When you write it out, even for the first couple of times, it definitely helps to visualize that you're seeing what's on top, what's on bottom, okay? Which is one of the benefits of doing this, at least in the beginning. Or if you ever get stuck, just set up the problem. If you're ever stuck, practice setting up the problem because it should help things out. So all you're going to do in this instance is you're just going to multiply across the top 120 times 60. You get 7,200, and then divide by the bottom 90, which will give, yes, I even guessed it wrong. It's 80 milliliters per hour. Because remember, whenever they ask you to calculate flow rate, they want to know it in milliliters per hour, unless they specifically ask you for the drop rate, which is drops per hour. Unfortunately, sometimes flow rate can also mean drop rate. You'd have to get that from the context of the question, and we'll go over some examples of that. Let me just check over here and see, because I saw I had some other questions. IB. Oh, did someone, I guess, Janelle, I think you were telling me which edition, so that might be true. Okay, good. 80 milliliters per hour. Okay. Yep. Yeah. So if you did 120 over 1.5, you did that right. I'll give you another example just because this will be helpful to see. So let me just do this right now. This way you can see this. So if I come in here and let's say it's 150 milliliters, and then let's say it's I don't know. Let's just say no, let's just do 35 minutes. Okay. I don't even know if this is going to work out properly, but that's okay. So it's harder, you might be saying like it's close to 0.5, but it's 35. So what do we do here? This is where setting it up with and then multiplying by 60 will be helpful, because that way you don't have to figure out what the decimal is. Obviously 90 minutes is 1.5. That makes it a little bit more straightforward. But if I'm doing this, and I'll let you guys kind of look at that and see what you get. Actually, go ahead and try and answer this one. Just see if we're all getting the same answer. And go ahead and just put your answer into the chat. And then for the person asking about getting 80 milliliters per hour, just multiply across the top, divide by the bottom. So 120 times 60, 120 times 60 divided by 90. All right, so remember, good. Yeah, if you're getting that 257, that's good. Technically you would round your answer. Yes, we're all a little rusty. It's not.
I just have a quick question, Dr. Red. I
Yes.
don't mean to interrupt you. I just want to reaffirm what you just said to make sure I have my notes correctly. So for flow rate, it's always going to be millimeters per hours. And then for drop rate, it's GTT over ml, right? That's the
No.
difference.
Yeah, so drop rate would be drops per minute, but I haven't gone over drop rate yet.
Okay.
Yeah,
But flow rate is always going to be millimeters per hour.
Flow rate will be milliliters per hour, correct?
Thank you.
You're welcome.
I have another question.
Yes.
So you said that we round this one, but for mine, I got like 257.14, and I was like, that's not gonna do anything, right?
It's not, but they do, like, if we're following the blueprint directions to a T, you would round it to the nearest 10th. So most likely you're not going to get a question that's going to incorporate a rounding like that. And you're right, it would be insignificant and it wouldn't mean too much, especially with that quantity. But if you want to be absolutely correct, you would want to put 257.1 milliliters per hour.
Okay. Since I've definitely screwed the rounding up, then can we do like a rounding problem? Like, are there gonna be like a metrics to household one?
Yeah, yeah. I mean, whatever you guys wanted to do. I just someone had mentioned IV, and so that's why I was spending some time on, because I think that's new for you guys.
Definitely.
But yeah, the problem is, like, the rounding really is going to come from, like you said, when you're going from metric to household or household to metric. And so that's where the rounding comes into play. But yes, we'll do that. And then Mara, I did see your thing about intake. We'll definitely do that as well. All right. So like I said, let me just double check and see. I don't know if you guys are doing drop rate this semester. So let me just double check the 220, 230. I think we are. Okay. Thank you for answering that question. It's not clear on the thing. So let me do a couple drop rate questions, and then I will get to the rounding stuff. So for just in generalities, you're always thinking about rounding, but there's 2 times specifically that you do not round, or at least you don't round to the nearest 10th for a whole number type question. And that's when you're dealing with drops, because you can't give somebody a decimal drop. You can give somebody 257.1 milliliters. That 0.1 milliliters is just what is 1/10 of a milliliter, and if you have the right equipment, you can certainly do that. Does that extra tenth mean anything for the quantity there? Most likely not, and 257 would be the most appropriate answer, in my opinion, but it's not up to me because I'm not the one grading them. They tell you that you need to round your answers to nearest 10th, so I let you know that. The other thing I'll let you know is that usually when they ask these questions, you don't have to worry about the rounding because they've taken care of that in the particular example. Just like the 120 milliliters in 90 minutes worked out to 80 milliliters per hour, you didn't have to worry about rounding because it came to a whole answer. That's usually the case. Okay. So just to give you a little bit of peace of mind. But anyways, let me work through. Oh, and the other time you don't round is when you're converting metric to metric. So if I'm going from liters to milliliters, or grams to milligrams, or milligrams to micrograms, and I'm just doing that basic conversion, it's usually the first like 5 questions you get asked on your test. You don't round metric to metric. Okay, you leave your answer. So if you have like 1.25 liters and you're converting that to milliliters, your answer would be 1,250 milliliters. You leave that alone. If you started off with 125 milliliters and you're converting that to liters, it becomes 0.125 liters. You don't round that. Okay. And again, that's the only exception with rounding where you're going to be tempted to round is when we're doing metric to metric conversions. And I will give you some examples of that. All right. So this will be a good one because there are some extra steps or extra information in here that you don't need. And it's good to see this because a lot of times you're thinking, holy crap, what else am I supposed to be doing? So for your flow rate or your drop rate questions, there's a couple things, pieces of information you need to know in order to calculate it. You need to know the flow rate. And remember, flow rate is the milliliters per hour. Okay. Now, sometimes your flow rate will be given to you in milliliters per minute, and then we'll talk about that in just a minute. So you need the flow rate. You also need something called the drop factor. drop factor is going to be drops per milliliter. If you don't have the drop factor, it's going to be very difficult to solve, but a lot of times they'll tell you that you're using like microtubing. Microtubing has a known drop factor of 60 drops per milliliter. So if you ever are looking for a drop rate and it doesn't tell you the drop factor, look for the 60 drops or use 60 drops per milliliter. 60. I very rarely have seen that question asked. But it has been asked, and so that's why I'm letting you know that microtubing has a drop factor of 60. All right. Now, when you put these two pieces of information together, what we're looking for is our drop rate, sometimes called drip rate, which is going to be listed as drops per minute. And you might be wondering why do they call it GTT for drops instead of DR? Well, because DR are drams, which is an apothecary unit, or if you have perfume laying around in your house, look at the bottle, it'll tell you it's measured in drams and usually either ounces or milliliters. But just so you're wondering, like, who uses drams? Health and beauty. And then obviously we used to use that too. We being as far as medicine is concerned. So how do I solve this particular problem? So I need to know two pieces of information. I need to know the flow rate and I need to know the drop factor. So I'm going to look at my question. Administer gentamicin, 60 milligrams and 50 milliliters, dextrose 5% water over 15 minutes every 6 hours. Gives me the drop factor is 20. So we know that even though it doesn't give me the units, we know that the units are drops per milliliter. Okay, it's how we convert what's coming out of the tubing. All right. So what is the flow rate? It says 50 milliliters over 15 minutes every 6 hours. So there's 2 times there, right? So what I'm looking for is the here and the now. So my flow rate for this question is going to be 50 milliliters per 15 minutes. Now, because I've trained you, you're going to be conditioned to convert that minutes to hours, but I'm going to tell you to hold up. Okay. Hold up, because what are we looking for here? We're looking for drops per minute, right? So we want it to stay in minutes. So don't convert minutes to hours, not in a drop factor. You do convert minutes to hours when we're converting flow rates, but to just a standard flow rate, milliliters per hour, but we're not doing that right now. We're doing a drop factor. Then, so we have our flow rate, but this time we're going to leave, like I said, instead of converting that to hours, we're just going to leave it at minutes. And we're going to multiply by our drop factor. Our drop factor is 20 drops per milliliter. Sorry, didn't mean to drop that so low. So here's our drop factor. Now you might be wondering, what do I do about the 6 hours? Well, that's just telling you that we're maintaining that flow rate every 6 hours. So it sounds to me like after 6 hours, they'd either reassess or reestablish what they're doing. So we don't necessarily need to worry about that right now. So I'm going to rewrite this because it looks horrible. All right, so 20 drops per milliliter. And then to make sure we're doing everything right, we cross out milliliters. We're going to be left with drops per minute, which is exactly what we want. So I'm going to take 50 times 20. Which gives me 1,000. And then I'm going to divide by 15. And I'm going to get 66.666666. Remember, I can't give somebody a partial drop. So I'm just going to round it to the nearest whole drop. And then I'll double check because I think some of you already wrote the answers. But this would be 67 drops per minute. Let me just see.
So we would write the GTT even though it isn't that like the same thing, like GTT in milliliters in a way.
They are not the same thing. No. Yeah. So GTT is drops, and literally, like if you've ever seen like a heparin drip, or even when they do morphine, it's in a drip. So it's coming down, it's dropping into the IV, and it's at a very low rate. So you're getting a lot of drops per minute, but it's very, very small. So it takes 20 drops to equal 1 milliliter is what that means. So you don't want to say that they're equivalent because it's not. And what decides what the drops per milliliter is the tubing that you're using. So you are going to see different things where it's 10 drops per milliliter, 20 drops per milliliter, 60 drops per milliliter. Everything's a little bit different, which is why you need to know that drop factor.
I just got confused because I seen flow rate at the end, so I just assumed it was like milliliter per hour.
So, and then this question, so you're right. Yeah. And that's the thing you have to pay attention to, because it says, what is the flow rate? And that might be a way that this question is added. So looking at the context of everything, it gives you a drop factor. So most likely they're asking you for the drop rate. Drop rate is a type of flow rate, is to maybe add some clarification. Drop rate is a type of flow rate, just like milliliters per hour is the standard for flow rate.
So if they ask for in the question, if it says drop factor, we could assume for labeling purposes, it's going to be GTT over the minutes.
That is, I think, a safe bet. And I also think that this is probably a bad example of how the question would be asked. But it's good for you that you're seeing that, because you know, after taking your 110 test, that there were some questions that were asked and you're like, what the heck am I looking for? But using the context of everything, if it tells you a drop factor, most likely they're looking for a drop rate.
This is actually a good question, because this is how I failed 130 from Dosage last year, because I messed up the labeling.
Okay.
So yeah, I put the mLs over hour instead of the GTT over minute. So this is a great question.
Okay. Well, good. No, and I'm, like I said, I would say the reason I would say bad question is just because, like, if I was asking this question, if I wrote the test, I would try and take out as much of the guesswork and just focus on you being able to, like, can you do the math? Like, that's what I'm trying to assess. But again, I'm not the one that writes your test, at least not at your campus, and I haven't written one for Allegheny campus, and almost, it's been what, 6-7 years, so it's been a while. And so yeah, so I would try and give some more clarification. But if it's me and I'm looking at this with fresh eyes, I'm thinking, okay, if it gives me the drop factor, most likely that means there's a tubing involved, and they want to know what the drop rate is. And then just in case you're wondering, like, what about this 60 milligrams? If you're wondering about this 60 milligrams, we don't utilize it because the strength or the concentration means nothing in the flow rate. And the example I've given in the past is whether you take a minivan to Kennywood or an Aston Martin to Kennywood, you probably have to go the same speed limit as everybody else. It's the same flow rate. Okay. Don't bring your Aston Martin to Kennywood. I don't trust the parking in that area. Minivan, it's fine. It's probably messed up in the inside if it's anything like my family vehicle. Okay. So let me give some examples of where
I already
rounding.
have a question.
Okay, go ahead.
So I just want to understand this. The drop factor and the flow rate all are GTT over minutes, right?
Drop rate is GTT per minute, correct?
Yeah, drop rate and flow rate.
Flow rate is milliliters per hour, but in this particular question, when we talk about flow rate can mean milliliters per hour, or we could be talking about a drop rate, which in this example, we are looking at that, and that would be drops per minute. So the real term is drop rate, drops per minute, and then flow rate, milliliters per hour. But drop rate is just another way of expressing flow rate.
Okay.
But using drops instead of milliliters.
Okay, thank you.
Mm-hmm. All right, so let me go back to where you might have some things for. So someone mentioned about rounding, and then they said that don't round weight. Well, it depends. I've always been taught, yeah, you would round weight, especially if you're going from pounds to kilograms. Let me give some examples of that. I'm just going to come up with these off the cuff. Just give me 1 second. I'm going to pull up your, yeah, we'll start with these and then we'll do some of these.
I have a quick question, Mr. Red. You know how like at 110 and 120, there was like a folder that had a whole bunch of like practice tests,
Yep.
like way more than the ones that were up in that folder for Allegheny. Will you be putting more practice tests on there?
It's just what is already there. So if you haven't been there in a little while, I mean, I would suggest, because I've been doing the reviews for Allegheny campus for several years. I only just started doing Boyce North and South over the last, like, I'd say year or two. So I just don't have the quantity of information, but it's all based off of the same, whatever it's called. It's based off of the same blueprint. It's just that there are some nuances that are a little bit different. So I am trying to build up. I'm adding this document to the 130 folder that I just created for Boyce. And so that way you can come back to it and pick out some questions and use it as a reference, a new reference tool.
Okay, thank
I'm
you.
just curious.
I'm sorry, I didn't mean to cut you off. Where is that folder located?
If you click on the link that says the link to the practice tests, that's where that is.
Okay, thank you.
You're welcome.
Dr. Rad, I'm just curious. Why are there different Boyce campus in Allegheny? Why are the questions slightly different?
It's just the way they're working on trying to put that together. So I don't know the answer to that. Some of it is probably my fault, just because I wrote the Allegheny test several semesters ago, or several years ago. And I didn't know, all I had was what Allegheny campus gave me. So I don't know the answer to that, like why they're not all the same or similar enough. I have no idea, but we are working on trying to fix that.
Okay.
All right. So so household measurements, and this will also be kind of like the intake question, because you're just converting your metric to household or household to metric. So I have plenty of really good examples of that in the Allegheny folder. So let me just pull those up real quick. That way I have them. There we go. And then I will add these questions. Oh, I thought I did. Maybe I don't. All right. Well, these actually account for these two things here. So let me just add them in. And then we can do an intake question. I think there would be time. Okay. All right, so these are questions that deal with both household measurement and converting between systems and metric unit conversion. So I just have two examples of each, and I'll give you another example here in a little bit too. Like I said, I don't like numbering, so we'll just get rid of that. And then we'll just take 127 pounds. Oops. Okay. So that way we can have a couple of things. So when we're converting milligrams to grams, right? Hopefully this is just a review. You know how to do this stuff. You need to know your unit to unit conversions. You need to know that 1 gram is equal to 1,000 milligrams. 1 milligram is equal to 1,000 micrograms. 1 ounce is 30 milliliters. teaspoon is 5 milliliters, tablespoon is 15 milliliters. You need to know those conversions. They are in the they're on the blueprint, but they're also in the different examples. But let me just add the one that I think will be most helpful for you when you come back to this. No, not that one. This is a good one because she adds a couple of extra ones. All right. I'm just going to add something to just folder here. This way you have access to what was done. So you can see all the different conversions. 1 teaspoon is 5 milliliters. This says 60 drops, but I would just be careful with that. That may not be true in all situations. 1 tablespoon is 3 teaspoons is 15 milliliters. 1 cup is 8 ounces is 240 milliliters. Pint is 2 cups. Quart is 2 pints. Then your grams, milligrams, kilograms. 1 kilogram is 2.2 pounds. 1 kilogram is also 1,000 grams, but typically we're not using this in nursing. I always say, like, the only time you hear about kilos and drugs is when it's illegally seized. They found, 2 kilos of, an illicit substance in someone's trunk or luggage or somewhere else. And so we really don't use that too much in a nursing situation. Pounds to ounces. And then you might see some meters, centimeters. You might need to know how to convert inches to centimeters. I don't have that listed here. But anyways, yeah, that's some of that's repeated. All right. So like I said, you should know some of these conversions already. You can just move the decimal point over, whatever's convenient for you. But if I'm doing this just for teaching purposes, I'm going to convert this using a conversion. 1 gram, 1,000 milligrams. And then I think you're going to get 0.075. So let me just double check. 75 divided by 1,000. Yeah. So my answer to this one would be, and this is where a lot of students will do something silly. They'll try and round that to 0.1. You don't round basic conversions. So when you're going from metric to metric, don't round those, okay? If you're a decimal mover person, for this one, just move the decimal over 1, 2, 3. And so your answer would be 0.125. Now, you may need to round if you go metric to household or household to metric. So you may need to round. Now for this, remember I mentioned this, that my equivalent or my conversion factor for this is 1 ounce is 30 milliliters. Now I can tell you right now, 30 is not going to go into 135 evenly. So 135 divided by 30, it's going to give me 4.5 milliliters. So thankfully I don't need to worry about rounding, but I'm not going to round that to 5 milliliters. I'm just going to leave it at 4.5 milliliters. If you had gotten 4.25 milliliters, then you would round that to the nearest tenth. So you'd round it to 4.3. So as an example, let's say it was another number. So let's just say it was 4.25 milliliters. Then you would round that to the 4.3 milliliters following the directions as it pertains to what your blueprint says. Numbers greater than 1, round to the nearest tenth, the exception being metric to metric conversions. And then you can't round to the nearest tenth because you can't give someone a tenth of a drop.
I have a question.
And then for numbers less than 1, round to the nearest hundredth. Go ahead. What's your question?
Why wouldn't that label be ounces?
Oh, I'm sorry. You're right. I made the mistake.
Okay.
Yeah, you're correct. Thank you for picking that up. Yeah, I was just right. I was just thinking milliliters the whole time, and you are correct. It would be ounces. Sorry. Helps if I don't screw up, so you don't screw up, right? Okay. All right, teaspoons to milliliters. Remember we said 1 teaspoon is 5, so 2 teaspoons is 10. And then converting pounds to kilograms, it really just depends. Sometimes I would say, yeah, don't round if you're using it in your equation to solve like a weight-based calculation, wait until the end. But I've also heard it argued that you can round to the nearest tenth. So there's some nuance there that I'm not 100% certain on. But I will show you this, and I will encourage you to round this answer because I don't think it's going to show up right. So here's one where you can do, if you're an ordered over half person, just remember you're always going to divide by 2.2 to convert pounds to kilograms. So 127 divided by 2.2 will give you 57.727272. So we're just going to round that to 57.7 kilograms. So you would not write out 57.72727272 on your test because it goes on indefinitely. So you do need to round that answer. The only time you wouldn't necessarily want to round that answer is if, like I said, let's say I have a 127-pound patient, they're to receive, 5 kilograms per milliliter of a particular, or 5 milligrams per kilogram of a particular medication. How many milligrams will they receive? Then you might want to save your rounding to the very end. But because we're talking about numbers greater than 10, the decimal point probably isn't going to matter that much. But in reality, but in the math component, they want you to see that. I don't have any examples of that, but just giving you a heads up on it. All right, and then let's do an intake question. All right. So let's do an intake question. And then that'll be it for today. All right.
One last thing, Dr. Red, I apologize. So
Yeah.
I was doing those practice tests that were in that folder, and it made us calculate the intake, but also like what would you make up for it, I guess you could say. Like the patient loses so and so milliliters, and then how would you replenish that? Would those be on this test? Because I haven't seen that in the last. I didn't.
No, not for you guys. That would be more for that's Allegheny Campus's intake and replacement question. So that wouldn't be you guys.
Okay, because I was getting scared.
No, and it's easier than it looks. So and then like I said, I need to correct that a little bit, but so let me show you. This is what you'll get. You'll get something that looks like this, where you have you're calculating the fluid intake. They're going to give you examples of a meal, and then you're going to have to figure out what each thing is in milliliters. Okay. And then paying attention to like what each thing, and the one thing that I'm not 100% certain on is like if you get custard and pudding and ice and things like that, that's something you need to look over your notes to see like what constitutes a fluid that needs to be calculated and what doesn't. But like for this example, everything here excluding the turkey sandwich is a fluid, right? So even if it told you a 5-ounce turkey sandwich, 5 ounces in that instance would be referring to its weight, not its volume. Okay. So for this question, half a glass, okay, which means what? It means 4 ounces. And then what is 4 ounces? 4 ounces. We're converting. So when we care about fluid intake, we care about milliliters. That's what we're trying to calculate. So we're not trying to calculate teaspoons, tablespoons, liters, gallons, anything like that. We're converting ounces to milliliters. So 4 ounces, the simple way of doing this is we know that 1 ounce is 30 milliliters. So I'm just going to multiply by 30 milliliters. So I'm going to get 120 milliliters for this. 6 ounces of coffee. So I'm just going to take 6 ounces times 30 milliliters. And I'm going to get 180 milliliters. So the only thing that really changes with this type of question is the foods and the quantities. And from what I've seen, that if it tells you a glass, it will tell you, because obviously if you're like, if you have this in your kitchen, like I have in mine, or my kitchen, or where my glasses are, I have different size glasses. I have juice glasses, I have water glasses, I have different size glasses. If you just have the 1 cup, you probably don't even know what the ounces is in it, and that's perfectly fine. Jello is 2.5 ounces. So I'm just going to take 2.5 ounces times 30 milliliters. So 2.5 times 30 is 75 milliliters. And all I'm going to do is, after I find all these, I'm just going to calculate it. I'm going to add it all up. All right. So a pint. So 1 pint is equal to 2 cups. So half a pint is just 1 cup. 1 cup. So I'm just going to write this out just so you can see. So half pint equals 1 cup, which equals 8 ounces, which equals 240 milliliters. And then you can correct me if I did anything wrong there. Pretty sure that's correct. Let's go back up. Yeah, 1 pint is 2 cups. So half a pint would be 1 cup. Then you just add those up together, right? So 120 plus 180 is 300, plus 240 is 540, plus 75. So 540 plus 75. And you'll get a total of 615 milliliters in this meal here. Jello, chocolate milk, orange juice, coffee, and a turkey sandwich. I'm trying to think, is this breakfast or is this lunch for dinner? So, all right.
Wait,
Let's double check here. Go
so
ahead.
for yellow, is it because it can melt?
Well, so I don't know if you've ever made Jello, but it's pretty much just water and powder. So
Yeah, but usually when they give it to you, it's like in a solid form.
right, but the only reason it's in a solid form is because of the powder that was added to it. So Jello is a liquid for all intents and purposes.
Okay.
And then this is going to sound dumb, but if you've ever done Jello shots, that would be another way to remember to constitute it, because it is predominantly liquid. That's the thing that's like a little bit challenging with like yogurt and pudding and custard, is because they also are predominantly a liquid component, but it's more considered solid, probably because it's not water. But I mean, it's
Another
milk.
dumb question.
So
What about, I remember in the test last semester, it said iced tea, and I remember you telling us something about ice. So I'm not quite sure if I got that question right, but
well,
I was
iced
yeah.
tea would just be, that's just liquid. That's just so, but the ice. So
That's why I remember thinking
if
it.
they tell you 8 ounces of ice, I think you divide it by 2 is what I think is how that is done, but I'm not 100% certain. So like I said, unfortunately, there's a lot of new, and this is new for me, and I probably told you that last semester with the fluid intake. I don't know all the details as far as the ice and all the different types of fluids and what's considered liquid or not. But what I have seen on some practice tests and things online is that if it has an ounce associated with it and it's definitely not a solid, like if it said like a 4-ounce turkey sandwich, then you assume that it's water or liquid and you calculate it out. But that's the thing, is I don't know about that for like custard, pudding, yogurt. I don't know all the specific. I think yogurt would just be considered a solid, just like you would think of that as a cheese, even though they're all dairy. Same thing for pudding. I think it's predominantly going to be considered solid, but Jello is considered liquid because I don't know why. It's just, but I think Jello shots and that usually is helpful reminder. So, all right. So like I said, if you have other questions, just email them to me if you can't come in on Thursday. And then if you have any other questions, like if you have any issues downloading, just let me know. Everything should work fine now. You just might need to do it on like a computer, because they're all like Word documents versus PDFs. But email me, because unfortunately I have to jump on another review session for the Allegheny campus. So if you want to come back here and listen to that review, you're welcome to do so. But otherwise, I will do a Boyce specific review with you guys on Thursday, same time, starting at 10:30. And then I'll pop in my email address again, just so you guys have it. And then
When will the new folder be done by, Dr. Rad?
so the folder's there already. It's just that I don't have the
This
thing
one.
uploaded, but in just a moment I'm going to save it there, and then it should be up and ready to go here momentarily.
All right, thank you.
You're welcome.
And this recording will be available on Zoom, you said? I mean,
It'll
not
be-
on Zoom, on YouTube. Oh, I apologize.
Yeah, it'll be on YouTube probably. I'll probably upload them either tomorrow or later today if I can.
Thank you.
You're welcome. All right, I'll talk to you guys later.
Bye.
See ya.